Today's a pretty easy day in my opinion. A lot easier than the previous days. The other days just take some time. They do start to become easier the more you do them. Things you need to look for are common denominators. Also need to look for, crap, what did I just think? Factoring and conjugates. Those are the three big ideas. Common denominators, factoring, conjugates. Hey! I like all your maroon today. So, here we go. Did I talk to you guys about the test being after spring break? For those that weren't here, it's after spring break now. Okay, here we go. You guys ready? Here it is. Where does sine equal root 3 over 2? You've seen these at least 10 times. Say what? Pi thirds. Look at Daniel go. He just popped that out like it was nothing. Is that the only place, Daniel, that it happens? 2 pi thirds. Do people agree with Daniel? Those are the two places that equals root 3 over 2. Now my question to you is, did I say 0 to 2 pi? So is that the only answers? There's an infinite amount, isn't there? Because remember, a sine graph looks like such. Woo! That's one cycle, but if I continue on, there's an infinite amount of places that equal root 3 over 2, right? Because it also goes this direction. You guys agree with me? So how do I get every answer instead of just 2 of the answers? Well, what's the next thing that we're going to hit? I would have to do what to these answers? Add 2 pi. Okay? Taylor, will you go grab the door for me, bud? That's a little bit louder than normal today. At least in my opinion. I don't know about you guys. Thank you. So, what I need to do is say, okay, well, if I add 2 pi, I will get back there. But that's only answering 4 of the answers, isn't it? What if I add 4 pi, 6 pi, 8 pi, 10 pi, 100 pi? Okay, what I need to do is actually put 2 pi n, where n belongs to the integers. Let me show you those things again. Belongs is just a backwards 3 kind of an idea. And integers, I just do like a normal z, but then I come back and come across. Does anybody remember or recall what an integer is? Is it irrational? Careful there. Not irrational. It can't be rational because a half doesn't work. It's our counting numbers and their opposites. That means belongs to the integers. Now the reason why this matters is, give me any integer out there. 7. What is 2 pi times 7? 14 pi. So that means I just went around the circle 7 times, right? Would I get answers by that if I added it to those? Sure. So therefore I can put any integer value I want in there, and that will allow me to have every possible solution there is. Is Bryce here today? No, Bryce. So what this allows me to do, now why is it important to have the integers? Why is rationals not good? Well, if I put a half in there, what's 2 pi times a half? Pi. Would pi thirds plus pi give me a solution that gets me there? That would be 4 pi thirds, and that would give me its negative solution, its opposite, but it wouldn't give me the solution, correct? That's why it's so important to make sure I'm using integers. That's why we have to declare that we're using integers. Any questions on that? So you have to have this whole thing. This would be one answer. So now in the back of the book, they might have this. They might separate it. You know what I mean? But I'm okay with just the comma in between saying, hey, I'm going to add it to both of those guys. Does that make sense? As long as you understand that that 2 pi n is going to both. But this says n belongs to the integers. You have to have that in there. So the E means belongs. That's another word for belongs. And the Z looking thing is the symbol for integers. If you want to know the other ones, our most basic is natural numbers, and it looks like this. Then our next number is whole numbers. I think whole numbers is the W, like that. Rationals is, which one's rationals? Q? I think it's the Q. Whole numbers. Rational numbers are the Q. Then we have integers, which we already talked about. Then we have real numbers. Yes. Yes. Those are the ones that we will know. I guess technically I could do 7 pi thirds plus 2 pi n. I mean, that's the same answer. Yes. You need to have something that's correlating to the unit circle. Does that answer your question? How are we doing so far? Was that really a hard part to do? Not too hard. The only thing new was, hey, we can get to infinite amount of answers by doing this, right? Okay, any questions so far? Let's go on. Okay, so let's do this guy. Anybody have an idea? What do you think? Okay. How about we just add, instead of 2 things, add him over here? That's the same idea. You with me though? Okay. So he asked to subtract the sign and the negative root 2, but I'm going to just subtract him over. One less thing to do, right? I don't have to do 2 things. I don't have to do 1 thing. Are you okay with that? Same idea though? So I have 2 signs of x. Does everybody understand where I'm getting that from? You guys are such a good combo. Huh? Yeah. Lickety splitty. You guys are so good. Bryn, who's in your group? Benson Kruger. Tommy. Gorley. Who was the other guy you said? Coldine! I love Coldine. Who doesn't love a good Coldine? You know what I mean? Coldine. He's like a mini celebrity. Hadley, were you in Coldine's class? Were you in 4th period last year? 2nd period. Do we know where sine equals negative root 2 over 2? We do, don't we? So x is 3 pi 4, not 3 pi 4s, cancel that answer. 5 pi 4 and whoever said that, I think that was Miss Bastion, but good job if it was. Dunk, are you going this Saturday? Who are you taking, brother? Vanita? Bernita. Spell that. Okay, Vanita. Where n belongs to the integers. Can I ask you guys something? What's the period of pi? I mean, cosine and sine. Somebody said pi is wrong. 2 pi. That's why we're adding 2 pi, because it takes a whole period to get back to where you were, right? So if I was on tangent, I'd be adding pi n, because it takes a period And their period for tangent is pi, right? Does that make sense to everybody? Understand where this is coming from? Tommy, you okay? You want to leg wrestle? A little later, maybe? Thanks, Tom. Tom, did you say there's another one of you guys coming along? Are you going to go here, or is he going to go to Lehigh? Yeah? What grade is he? Ah, he's my daughter's age. Wonder if him and they go to the same bus stop, I bet. Did you go to Willow Creek or did you go to Vista? Oh. So he goes to Lakeview. So that's why you came out here, is because some of your pals were out here. That makes sense. Anybody tell me how I'm going to solve this one? Add the 1, divide by 3, right? And then I need to take the square root. Wow, you guys are fast. If that's what you want to do, I'll just go there. But when I take a square root, what do I need to do? Plus or minus. And I need to rationalize. It has a nice human staple on it. Taylor's a stinker winker. Daniel, thanks for playing chess with me, brother. Would you like me to show you? Did she beat me too? You tell him. Okay, how I did that, what's the square root of 1? 1 over square root of 3. And then I got times square root of 3 top and bottom. Remember doing that stuff? Man, I lost 4 straight games of chess. Whew, my ranking's going down a little bit. Huh? This round you're doing all right. Okay, so where does tangent equal root 3 over 3? Tangent's a little bit harder one to think about, isn't it? This is, by the way, the root 3 over 2, comma, half. Pi 6. Nope, it goes square root of 3 over 2, root 2 over 2, 1/2 for the x value. Other way around. So this is, as you said, what is it then? Pi 6. Where else is it positive at? Negative pi 6, but I don't want to write negative pi 6. 11 pi 6, but notice, can I get there just by adding what? It's actually not 11 pi 6. 7 pi 6. So if I just add pi, though, that will get me to 7 pi 6. But I also need, because it's plus or minus, I also need 5 pi 6. But then when I add pi to it, it'll get me to 11 pi 6. So therefore, because of the plus or minus, does everybody understand the plus or minus added me another solution? So this is, once again, I need to have n belongs to the integers. Another one? Daniel, go check. So my cousin's wife beat me? That's just sad. Wow, yep. Straight up destroyed. I'm using chess time. If you ever want to get it, I'll play anytime. I play Daniel. Like I'm going to move on Daniel right here. That sounds really bad, but we're going to be okay. Yeah. Mine's, what's my username? Roberts BJ, Daniel? Is that what it is? Roberts BJ. App. Because when I put plus pi n, could n be negative 1? And then that's pi 6 minus pi. Well, yes and no. The reason why it's a no is because I'm not saying what is the arctangent of something. That's because remember, arctangent, for it to be a function, had to be between something. Here I'm saying, where does tangent equal this thing? Hey, babe. This is a class. Come on in. We can chit chat. I forgot to record. I was stopping recording while Bailey came in. So technically I subtracted that over. And the reason why I didn't divide cotangent over is because it eliminates answer. Would you never want to divide by a variable to eliminate it? Because it eliminates possible solutions to the problem. Does that make sense? And I'll show you in just a second. So cosine squared of x minus 2. Now I have a number times a binomial, so don't I just set each of those guys equal to 0? I have a binomial times a number, right? Because isn't this right here just a number? Cotangent of x, that's a number, right? You don't think of it as a number, but it is a number. When I plug a value in, don't I get a number? You guys are doing so good. One more class. Is A4? Yeah, get A4. You can do those. I'd love you to do those. No. You know what, prom queen? It is true. She is a princess, not a queen yet, because she's only a junior. So in my high school, though, junior, you had to be a junior to be prom queen, because it was junior prom. She's a junior. Where do you work? And you said yes? What? Money? You turned down money. What are you turning down money for? You're going to Hawaii today? And yet you didn't say, Mr. Roberts, I'm going to be gone all next week. What if I had a test? You like to extend your trips. Nice, which is great. It's up to you, whatever. Your test is going to be hard when you get back, because you're going to miss 2 sections, the harder sections of this test. So where does cotangent equal 0? Remember, that's x and y. X over y. So we want to know when x is 0, don't we? Where is x equals 0? Yeah, I split up just like you would. Think about it like this. Isn't that like x times x minus 2? Don't I set both of those equal to 0? Okay. I'm going to get there. I'm working on the left side right now. I don't know about you guys, but I know where cosine or x equals 0 is at pi halves and 3 pi halves. But notice they're only a difference of pi n, hence cotangent. Cotangent's period's pi, isn't it? Okay. Now here, I take the square root and I say, okay, where does cosine of x equal plus or minus root 2? So by the way, if you divided by cotangent, would we have got these answers? Does that make sense? Okay. Where does cosine equal root 2? I know where it equals root 2 over 2, but do you guys know where it equals root 2? It doesn't. Can cosine ever be greater than 1? No. With the highest our unit circle goes. So ratios go, only the highest it goes is 1, right? So that answer is gone. There's no answers there. So if we divided it out, notice I would have got rid of all the answers. What am I missing, though? I haven't wrote it yet. Where n belongs to the integer. I moved on you, Daniel. Daniel, that's tricky. What's downloading? We'll see what Daniel does here. We'll do a little Daniel trade and see if Daniel wants to mess around. Come on, Daniel. I had Park. Okay, so notice the key thing here is cotangent has a period of what? So there's only one answer there. Plus another guy. So if I add him over, add pi to it, it'll just get back to us. The two places it happens is pi happens, that's situated by pi. If you did pi halves and 3 pi halves plus 2 pi n, would it be wrong? No, it's just not simplified down all the way. Answer your question? Because there's two places that it's happening. Okay. I gotta think of what the other one was. Kaylin, do you ever come here and think, why am I here? You can be honest. Do you enjoy coming to this class? Most of the time? Is there sometimes I'm annoying and bothersome? Oh, so it ain't me? I like you. Look how you played that. I like how you played that, Miss Kaylin Bacon. Sabrina, how was Boston? Would you bring me back? What? We talked about this. You even went to the Red Sox. You went into Fenway, and you didn't even think of me? I will have it. When you saw a shot glass, you didn't think of your teacher, Mr. Roberts? That's great. I'm not a drunk. I used to collect shot glasses myself back in the day. Huh? No. Swedish and English. A little bit of German. On the 16th. Like mooned or flashed? Ah. Okay then, let's go on. Don't want to record that too much. So, ladies and gentlemen, on this problem, what's different this time? I can't factor something out. It is all on one side as well, but notice I have two cases, but this time I can't factor it out to have two different solutions. Can I make it all in one term? What could I do? 1 minus. Everybody understand what Curly just said by 1 minus cosine squared? Because then, now notice everything's in terms of cosines. Is everybody there with me? Yep. Yep. Look at you go, Taylor. Taylor, how is it to have a name that is now used for male and female? You want to know why? Taylor Thomas, Jonathan Taylor Thomas, JTT. The people loved him. He was on Home Improvement. He's the voice of Simba, the baby Simba. Yeah. Yeah. So I'm going to get everything over. And when I do so, the reason why I do so is because I can factor this side. I just don't like to have negative leading coefficients. Me personally, I struggle with that. I'm just silly. That's why I don't have OCD, but that's one of my OCDs, I guess. Hey, the handwriting looks pretty good, doesn't it? What's 2 minus 3, guys? -1. So technically I'm adding 1 to the other side, right? Anybody have a question on how I got there? How is it being a friend with Coldine? Freaking Coldine. If you don't know who Coldine is, you don't know anyone. Because Coldine is a rock star. He was in this class for a day, wasn't he? Or fourth period. Yeah. Any golfs? No. No, that's Gibby. I like Gibby. Jared Gibby. Cold free. Should we pull up Coldine? We'll push pause. Factors. I went ahead and factored, and then I set them equal. Oh, I think it can. You want to know where? Pi thirds. And 5 pi thirds plus 2 pi n. Right? How about where does cosine equal 1? Ooh, no. Oh. You found out where tangent was equal to 1. I mean, sine equals 1. You found out where tangent equals 1. And you found out where cosines equal 1 at. And 4 pi. Maybe you're far way over there, okay, Sabrina / Shelby? I know, but today you are a little bit when I want you to be. Did I ever tell you? Do you want to see who this? Here, we got to push. Anyway, she's a redhead. Well, you still have some red tint. And so therefore, guys, this answer was 0 plus 2 pi n, right? But what's 0 plus 2 pi n? Huh? Infinity, you say? Just 2 pi n, huh? So therefore, it's just 2 pi n. That would be our answer there. Well, what's 2 pi n? Couldn't I put 0 in for n and make it 0? Say what? Yeah, I mean, it's the same, but I'm just showing you why, if it looks different in the back of the book, why it might look. What up, Dunk? Okay, so you would have to, if you were going to do the whole answers, everybody, you would have to go x equals 0 pi thirds, 5 pi thirds, plus pi n, 2 pi n. Does that make sense? Because all of those are adding 2 pi n. That's how you'd have to have that. Next. Okay, we're getting close to being done. We got 3 more examples. It is. It's just different situations to see them. Like this guy right here. Sometimes those people don't know how the hell to turn in paper. Yeah. Darn you, before. Before what, they say. I hate when people say that. Okay, just like the last problem, notice I have 2 different trig functions, huh? If I subtract the sine over, am I able to factor something out? No, so that doesn't really work. So how can I get rid of a sine, or how can I get rid of a cosine and put it in terms of sine and cosine? Now, some people are asking me, Mr. Roberts, can I just change cosine of x plus 1 into sine? Because it's not squared, I can't do that. And first off, it needs to be a minus. But anyway, I can't do that. Yes, do you have an idea? Okay, that would work nice, but then I got to change cosine squared into something, so that just comes back. Not quite there. I don't want to do that yet. That is a good idea for a little bit. Anybody? Once again, this is not verifying, this is solving. So on solving, I can play on both sides. I could times both sides by cosine, but I'm not going to. Good idea, but no yet. But then I'd have 1 over cosine, which is secant. I'm going to square both sides. And what happens here is I get cosine squared of x plus 2 cosine x plus 1 equals sine squared. Good job. There you go. So I'm going to say, oh, this is 1 minus cosine squared. Now I have everything in terms of cosine, don't I? Okay, so I subtract him or add him over, so I get 2 cosine squared. Plus 2 cosine x. Now, when I subtract that 1, that cancels out the other one, and I get 0. Say again, I'm sorry, Curly. I subtracted that 1. Oh, Dan's ready to play. Dan, you took my knight for a knight. You decided a knight for a knight was worth it, huh? Dan, I was hoping that we could play a little longer with knights. But I would have taken your knight for a knight. Okay. Now, what did you say, kind sir? What did you tell me to do? Girls, are you okay? Basically, this is saying where does cosine of x equal 0, because I divided the 2 over, but I'll keep it there for right now. And this is saying where cosine of x equals -1. Now, this one's easy. This one's pi plus 2 pi n. You're killing me, Taylor. Taylor, you're killing me. Taylor, you're killing me. And where does cosine equal 0? Happens at x equals pi halves, which is just plus pi n this time, isn't it? There they are. Oh, Dan decided to play with the queen, huh? Okay. What's the 2 answers where cosine equals 0? Pi halves and 3 pi halves. They're not situated, like then I could get back to 5 pi halves and 7 pi halves and 9 pi halves, but isn't it every pi that it's happening? Pi halves plus pi gets me a 3 pi halves. Plus pi gets me 5 pi halves. You see how I could simplify that down to make it a little bit nicer? Okay. Oh, whoa. Thanks for telling me about my symbols. Because you're learning a language. An interesting, delicate language. That gets a little temperamental when you make her or him do things that they don't want to do. And they're like, no, you're wrong. You treated me in a bad way. All right. Oh, that's a 2. That's a 2. Sorry. Dan Warp. Just look up Dan Warp. But it doesn't matter. No, you just got to invite to a game. What's different this time, ladies and gentlemen? Hello. You are such a good rock star gal. Okay, guys, difference here is, notice that 3x. What does that 3x do in our graphing? Did you guys cook the pizza? What are you doing? Did you eat it? Oh, okay, so you did eat it. Okay. Yes. So, let's keep on math for just a moment. Just a moment. Just a moment. What does that 3 do to our period? It shrinks it, huh? Roberts, BJ. No. Okay, so I say to myself first, where does sine equal a half, which was our very first example of today, wasn't it? And that place is at where? Pi 6 n, 5 pi 6 plus 2 pi n, right? Exactly. But am I searching for 3x or am I searching for x? So I need to divide this by 3, by this by 3, this by 3, this by 3. I need to divide everything by 3. Okay, and let me show you why. If I plug pi 6 in here, what's 3 times pi 6? Or excuse me, sorry. Pi 6 divided by 3. That comes out to be pi 18ths. I apologize. Give me 1 second and I'll come back to it. 5 pi 18ths plus 2 pi thirds. Does everybody understand why it's 2 pi thirds n? And that should make sense because my period changed from 2 pi to 2 pi thirds. So now every 2 pi thirds, I'm coming back to where I was, right? Everybody with me on that? Now, watch when I plug pi 18ths in there. What's 3 times pi 18ths? Pi 6. And what's the sign of pi 6? 1/2. So does it work? Sure. Now, that right there, where n belongs to the integers, I'm starting to forget that, I apologize. That tells us every solution. What if they're looking for only solutions between 0 and 2 pi? Nope, that would not be all my solutions. That would only be 2 solutions. So here's what I do. If they wanted solutions between 0 and 2 pi, I'd have pi 18ths. I'd have 5 pi 18ths. Okay, and then I'd have to add 2 pi thirds to each of those. 2 pi thirds is, by the way, 12 pi 18ths. So if I add 12 pi 18ths to pi 18ths, I get 13 pi 18ths. If I do it again, I get 25 pi 18ths. How do I know I have to keep going or stop? Because 2 pi is 36 pi 18ths, right? So if I add 5 pi plus 12 pi, that's 17 pi 18ths. And then one more time is 29 pi 18ths. All those solutions are between 0 and 2 pi, aren't they? Okay. Last problem. I'm going to subtract the 3 over. Curly Fries has invited you to a game of chess. Thank you, Curly Fries. Your turn, Curly Fries. Hey, so am I. Ask Daniel. Daniel is being... It depends on each game, right, Daniel? Okay, I'm going to show you 2 ways to solve this. I'm going to show you this by hand and by using your calculator. Yep. Okay. So I want to find all the solutions, okay? Hey! You're back. Let's hurry and do this by hand first. I notice I can factor this. Okay. So then I say, oh, where does tangent equal 3? Is it? Yes, it is. Thank you. And where does tangent equal -1? Okay. Can tangent equal 3? Sure. Is it a unit circle question? So what do I need to do? Go to my calculator, and I'm going to go ahead and find the arc tangent of 3. It gives me 1.249. I'm going to say 1.25. Is everybody okay with 1.25? Should be in radians, yes. Okay, 1.25. So I come back, I'm going to go over here. So x is 1.25. But notice I'm good there because all I have to do is add pi n to find my other answer, right? Because knowing my period, correct? Okay, where does tangent equal -1 at? So all I have to do is say x equals, sorry, I forgot my x again. X equals 3 pi 4s plus what? Pi n. Where once again, n belongs to the integers. Okay, now I'm going to show you via the calculator. If you recall, the very first thing I had was, let me just clear these. I had tangent squared, right? Am I correct in that? Tangent of x, so this is how you do it. You do tangent of x, and then I need to actually clear that. Let's clear that. Go parenthesis, tangent of x, close, close, squared. Wasn't it squared? Minus 2 tangent, is that what it was? Yes, 2 tangent. Thank you for those looking, sorry. And then it equaled 3, didn't it? So guess where I'm going to put 3? On the next line. And then notice, guys, the things that I want you guys to look at is zoom. I want you to do zoom trig. Because we're in trig stuff, aren't we? It'll make it a lot prettier graph. Okay, if you'll notice though, it's the same graph over and over and over again, right? That means it has a period, correct? Now what I'm going to do is I'm going to find this intersection point and that intersection point, and I'm pretty sure if I found that point, it'd be adding pi to it, right? Because it's a tangent. Does that make sense to everybody? So here's what I'm going to do. Anybody remember how to find intersection? Second, calculate. Number 5, intersect. So I'm just going to push him over to where it's closer, getting closer to intersect. Oops, back away a little bit. There we go, that's fine. Enter, enter, notice, enter again. 1.249, didn't I say 1.25? Same answer, huh? Notice, watch what I'm going to do right there. I'm going to find that intersection. So second, calculate. Number 5. So this time I'm going to push over again. Here he comes. He's coming. See him? Enter, enter, enter. Pi fourths. That's 2.3. Is it? No. Didn't I have pi fourths? 3 pi fourths. That's 9 divided by 4. That's 2.25-ish or 2 point something, right? So there it is. There's pi fourths. And I bet if I found this solution, it'd be 1.25 plus 3.14. So I bet it'd be 3.39. No, on your remember how I said number 47, use your calculator? That's how you would do it. Is everybody with me? Do you need help on yours? Okay, let me see how you plugged it in, okay? But for everybody else, that's it. Here's the homework once again if you forgot, or if you're not here. Page 396, 711, 19 through 39 odd, 43, 47. Please use your calculator, 57 and 59. Thank you for a nice day.